Welcome back, and my name's Blades, and we're gonna get all of this lot sorted. Just spent a couple of days on it, the weekend mainly, and yeah, I was right. I didn't like anything. So the .h file we're going to change. For starters, gluint. I've just realised why I was hesitating with it all, and I'm still hesitating with it also. I'm not going to do anything about it at this point in time. These vectors, no, we can't use them. The reason is because vector is not a .h, it's C++. If you ever wondered why there's no .h on vector and string, it's because it's C++. Anything with a .h is actually C. There you go. The C standard is .h. There we are. So that's explained that bit. And that made me realise that standard vector, well, we can't use it. No, we can't. So we're going to have to delete that. What it is OpenGL is written in C. Very clever, huh? Means all of this lot is a complete waste of time. But if we're only going to use the address, which is what star means, we're going to need to know the size. There's no point in telling OpenGL, oh, this is where it starts, if OpenGL doesn't know where it stops. So what we really want to put in here, we would like, oh dear, my keyboard's in the wrong place. Oh dear, come here keyboard. Come on lad, we want to type. So what we're really looking at here is we need to have size of indices, and keyboard's wobbling, stop it. And yeah, we can use that gluint, it doesn't matter. We can use it if I spell it right, because it's G, capital L. There we go. So that's what we're really looking at. So we want int size of positions. And it's just float, isn't it? Yep. There we go, that's that one done. We can have int size of x cohorts, comma, float. So it's roughly the same thing, but just split down into its component parts, because this is really what a vector records in C++. Of normals, isn't it? There we go. And that's a float as well, isn't it? Yeah. Normals. There we go. All done. That was easy. So now we've got the correct variables there. The only other thing I want to change is the order of these things here. It doesn't matter which order they're in. It's just that, well, I want to put that stuff before the thing I'm going to gloss over, which is the GLSL bit. Although I will have to explain a little bit of the data into an attribute list, I suppose. Attribute list is how it is where we tell OpenGL what to do, how to use our data. We can put mathematics in there, basically. And OpenGL will perform those mathematics using GLSL. I think they call it a shader. Yes, they call it a shader. It's got nothing to do with light, but light will be included, don't you worry. Let's pop that back to there. That's looking a lot better. Yeah. Standard string, yeah. I mean, could have used glint and GL floater, as I said before, but what the heck's the point? Right, I'm happy now. Yeah, I know. Right, there's no silly bits on this one, is there? There's no getters and setters because this is the heart. This is a functional heart. This is the thing that uses all the getters and setters. So I want to take from there to there. And I want to copy that lot. And we can now, yay, we can start. So let's namespace up. I'm really happy because I was spending 2 hours on Sunday, well, it was 6 hours on Sunday morning in the end, working out the data types for this. So, and I had to go to Windows to find out whether Windows would accept it. And it took 2 rewrites, but it did in the end. We got it right, because what we're doing is converting from C++ into C at the same time as converting from loading the data and sending it into OpenGL. Yeah, fun, huh? API, isn't it, we're using for this? Yeah, we are in the API folder. Yep, that's good news. And all I want is a V, Control V. There we are. Right. Shift Alt, drag. Backspace. Thank you. Don't need the private bit. Shift Alt, drag. There we go. Everything's on the same line. And this is DataLoader, isn't it? So we'll copy that. And if I'm right now, we should just be able to do this quite straightforward. Yep, we should. So blah, blah, blah. You're a member of DataLoader. So we'll put you as a member of DataLoader there. You're a member of DataLoader. That's a title mark if you can't see it properly. It's not a minus. It's a title mark, which on an English keyboard is just above the hash. On an American keyboard, I can't remember, but I think it might be on the above a number. American keyboards, I can't remember. Sorry, don't use them. Glue in load texture. I'll have you as a member, please. 8 VAO as a member. Unbind VAO we'll have as a member. It just makes more sense if you have them in this order. Let me read down the list of what I've done. And that store attribute data. Everything is a member of DataLoader. There we are. Let's just get rid of these semicolons. There we go. I would like a space between them as well, please. It's just readability, that's all. It's not needed. If you're interested, spaces are completely ignored in C++ and C programming. It doesn't matter. It's for display, it's for human eyes only, literally. It's so that we can make it easier for ourselves and make it easier to read. That's all. Make it look pretty. That's what we want to do. Yes, there's a few functions we're going to be writing here. And we are going to be writing them in reverse order. Interestingly. Try it again, haven't I? Okay. I've messed that up. My apologies. There we go. That's a lot better if I do it that way. I will put a space in just in case I need to put anything else in. So I'm going to start at the bottom. Because then we'll just get the silly bit out of the way. which is store data in attribute list. Float data, gluint attribute number. Yeah, okay. Okay, this is where we get our VBO from. Oh gosh. Gosh. Blades. Blades, what are we talking about? What are we talking about? You might just be reading this from like 2 minutes ago from watching the previous video. Well, the previous video, this is Monday, was last Friday for me. So let me just go back to our API. Yeah, this bit is our VBOs. So the reason why I'm glossing over this is it's the buffers. Now, all the buffers we're going to be sending through to the graphics card. The graphics card will want to know how to use these buffers, and we are going to link them to the GLSL code at the same time, so that our graphics card, when we present it with the GLSL card, will know which buffer, i.e. buffer 0, 1, 2, etc., 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 it can use. Now, let me just have a look. Attribute number will be the buffer number. Okay. Number of data is wrong. I think items per data is correct, and data itself. Let me just check on num data, because I think that's wrong wording. Let me get that out of the way. I do apologise, but I'm not happy with num data at all. Where's it coming from? Num data is coming from load to VAO, according to my notes. And it's coming in from size of. So it shouldn't be num data at all, it should be size of. And if I look at what we're going to be using it for, it's size of. I'm just looking at which command we use it for. Oh, silly me. Okay. That isn't num data at all. It is size of. Have I used num data anywhere else? No, it's just this one. Yeah. Header file. Make sure we name our variables in the same way. Well, if I'm going to be critical about that, you don't need to. You can name them whatever you want. You can name them one thing here and something completely different in the CPP file, as long as they match up on ints, gluint, int, float. That's all it really cares about. The names, it doesn't. Names are just tags. They're for us, the programmer. They're not for C or C++. They're just so we can read it properly. Now, I said it's for the VBOs, so we are going to need to use a VBO. So, gluint. See, it comes up on my screen now. Look at that. Gluint, we've got them. Type def, unsigned int. Told you they were. VBO. And we will have an ID, because that's what we're interested in on this one. Now, VBO stands for Vertex Buffer Object. Oh, why did you just do that, you silly computer? There we go. Semicolon I meant to press. It's alright, I wasn't looking at my keyboard. I'm stupid like that sometimes. I really should look at my keyboard when I type. VBO, Vertex Buffer Object. The ID is used in the same way that we were doing textures, texture loader, CPP. So this is exactly the same idea as texture ID here. And we're going to use it in exactly the same way as we used textures here, the OpenGL stuff here. So what we need to do next is generate it and bind it. Here we go. So it's GL gen buffers. And we've got to do it correctly. It's one buffer, and it needs, or it asks for, a gluint star buffers. That means it wants an unsigned integer address of the buffer. Well, it already is an unsigned integer, so it just needs the address, which is an ampersand sign, and VBO ID. There we go. Next, we can bind it. So bind. That is buffer, isn't it? Yeah, it's just a buffer. Buffer object, after all. Yeah, we can bind a buffer. It's, what type is it? Well, it's not a texture anymore, is it? So it's a GL and it's an array. Yeah, it's an array buffer. Is it just array buffer, or do we need anything else on that? Binding ARB? No, just buffer will do. And we want to bind it to our VBO. There we go. It didn't ask for the address, did it? No, it didn't. Just me double checking. Yep, I'm having one of those days. Better grab me coffee. You better grab yours too. We could be in for a bit of a haul here, because it's OpenGL, and that means I'm reading off my notes. Too many commands and too many of these macros, these hash defines to remember. Macros, basically just a number. Right, we've bound it. Now, look under texture loader again. What did we do next? We told it how to use our data, or what our data was in GL text image 2D. So we're going to have to do that. Well, we better do that, haven't we? So we have found it. And now we are going to tell it what data, buffer data. Yes, please, we'll have that. GL array buffer, isn't it? This is where it comes in. It isn't num data at all, as you're about to see. It's a size. Come on, look it out the way, please. You're right in front. It's size. As you can see, it's underlined just above, next to my cursor. Oh, if you're ever wondering why it comes up with that PFNGL buff, blah, 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 that stupid thing, that is a macro. And, well, the GL buffer data procedure, what's PFN? FN is function, so P will be procedure, won't it? I suppose. I think. I'm not sure on the P at the beginning. There you go, it's a function. Oh, yeah, who cares? We need that size I pointer. GL size I pointer size. And we have that cutely stored in num data. Sorry, size of data. There we go. So we can put that in there. Now needs a constant void star data. Well, that's our data itself. So our data is already a star. Yeah, our data will be one of these here, these three. Not the indices. The indices has its own thing. So the data will either be positions, text coordinates, or normals. So that's already got a star on it. quite happy. That matches up. I love it when it matches up. Num usage. Now you can look online if you go to OpenGL and search for glbuffer data. Go to the OpenGL site and look at that and the different usages it can have. What kind of usage do we want? We want static usage because we're not intending to change any of the data that we are going to be using. We're going to use GLSL to move, rotate, and do the operations on the data to place them on the screen. The data itself for each object will never change. So we're going to store it on our graphics card as GL static, and it's a draw because we're going to be drawing from the data. That's a hint to OpenGL as to what we are going to be doing with the data. We can do anything we want, but OpenGL thinks that that's what we're going to do. So what it will do is it will place it in memory, which is either top, high, middle, or low, which is high usage, average usage, and low usage. So yes, the memory on a graphics card is a bit more complicated than people think. GL static draw will probably be placed into average, I would have thought. No, it will be placed into high usage. If it's static, it won't get touched. Let's have a look. What else do we need to tell the computer? Oh God, something that we haven't really talked about. Now, remember that we're putting these into here, into this vertex array object. Well, the array object will need a pointer, to point to the memory address. So we better make a pointer for it. The command we're going to use is a GL, like this one, and it's vertex attribute. And as you can see, there's tons of them. Oh, it's the same as what we've used before, isn't it? Just realised. But we're going to be using the pointer variation of it. So it's a trib. No, it's not. Vertex attrib pointer. Please, no, it's me. Is it A-double-T for a trib? Yes, it is. Attrib. Dear me. Pointer. P-O. There it is. Found it. P-O-I-N-T. There we go. Pointer. So as you can see in texture loader, we didn't use it, did we? Oh, we didn't. We used the text parameters. It's a similar kind of thing to this. That's what I was thinking of. But anyway. So the attrib pointer will be the attribute number, which is 0, 1, 2, etc., etc., etc. We will be telling it which attrib number it is. So we better put an open brackets, haven't we? Here we go. So it's a pfngl vertex attrib pointer procedure. GL uint index, or attrib pointer, or attrib number. So we'll put that in. So I've actually called it for once. Attrib number. We're going to designate that. That's up to us. So we can choose which buffer, 0, 1, 2, 3, 4, etc. Okay. Next it wants. Oh, sorry, I read it wrong. Oh, index. Yeah, that's right. Glint size. That's the items per data. It's the actual size of it. So what it's looking for there, if you read up on it online, I call it items per data. It is a size, it is the number of items. So for a vertex, there are 3 XYZ items per data point. For a texture coordinate, there are 2 items per data, as there is a U and V coordinate, as I call them, or OpenGL calls it ST. I'll stick to UV, thank you. What does it want now? GLenum type. What type of data are we using? We are using floats. They're all floats, aren't they? All those data types. Yep, float, float, float. So it's only for these 3, remember? So it's going to be 012, if you really want to know, for the attribute number. Yeah, it's going to be that complicated. So we'll use a GL float. As you can see, that comes up nicely. If it doesn't come up, by the way, on IntelliSense, on whatever system you're using, whatever IDE you're using, query your IDE and glue. Your glue might not be set up right. It's a little bit awkward there. Boolean normalized. False. We are not going to be making it to size 1. That's what normalized means. Have we made our data into normals, which is size 1? No, we're not. Switch that on. What it'll do is it'll take your 3 items of data, or your 2 items of data, and make it into a vector size 1, most likely. Or it'll do something damn strange with it. So what we're going to do is we're just going to put false in there, which is GL underscore false. Leave my data alone. I want it as it is. I'm going to tell it to do there. Stride. What's the space between each item of data? None. There isn't any. We are using separate buffers for each item of data. If we had used 1 buffer for each item of data, then there would be gaps between our items of data, because they will be in, for example, I'm just going to give you a quick example. For example, we might have done a buffer that was position text coordinate normal, position text coordinate normal, position text coordinate, and just had 1 and called it a float start buffer. Yeah, so the stride would be the size of positions, the size of text coordinates, plus the size of normals, all of those, the size odds added together, because that's how far it would be before you get to the next one, spacing wise. And the last part of it is a constant void star pointer. And that we are not going to use either, because that is the offset. I wish they would say offset and not pointer. It's constant void star offset. How far into the buffer would you like us to start at? That's what it actually says. So for that, I'm just going to use null pointer. Don't. Nothing. 0. Want to start at the start, please. That's what it's asking for, so that's all we're going to give it. And yeah, we have to unbind it. We've done it all. That's it. That's all we need to do. So now we've done that, we've bound the buffer. Sorry, we've generated the buffer, we've bound the buffer. We've sent the data to the buffer, and we've told OpenGL where to start in the buffer. In other words, at the beginning, and this will tell OpenGL all about the data, its size, where it is. This will tell it that it's floats. This will tell it how many items it will have per data. 3 floats make a triangle, so that will be 3 most likely for most things. Text coordinates will be 2, obviously. Once we've done all of that, we've switched all the switches, and like texture here, we've done it, we've switched all the switches, we've described the data. Well, what's the next thing we do? We unbind it. How do we unbind it? we set it to 0. So we do exactly the same as we did with texture. So it's glbuffer. Again, that's an interesting way of spelling it. Buffer. And it's GL array buffer. Oh, sorry, I'm having problems with my hands. Array buffer. And it's 0. If you remember, the 0th buffer. So I was wrong here. He thinks. No, I'm not. We start at 0. Yeah, that's right. The array buffer, the VBO ID, is not the same as the attrib number. That's where I just got myself slightly confused. They're two totally separate things. The attrib number we'll be using in the GLSL, and the VBO ID is the thing that we will be using in here. The VBO ID. Oh, sorry, we will be using in this line here. It'll actually start at 1 most likely. Yeah, how to confuse people. So those two are totally separate things. That probably starts at 1, and then no, for a fact that starts at 0, because 0 is normally the position. Yeah, I'm happy with that. Is that all we need? Oh, no. Yeah, I've just remembered. Yeah, we've made these up at the top. Why? Because what we're going to do is later on we will want to delete all of these. And remember, they're not on the computer, they're on the graphics card. So when we finish our program and we leave our program, or sometime during our program, if the data is no longer required, we have to delete it. Now, C++ does not automatically delete other devices' memory upon exiting. It has to be done by the programmer. So at this point, we have to do the memory management. And to do that, we are going to record the VBO. So MVBOs, plural, because there are going to be many of them. Yeah, it's just a simple dot pushback, isn't it? Pushback. And it's the address of VBO ID. That's asking for. You can tell from your tooltips what it's asking for, so there shouldn't be any surprises of what I type in. Should just be surprised on my bad keying today. I have to make you aware that I am struggling with my hands today. I do apologise for the length of time it takes me to do things. It's not your fault, it's mine. Let's have a look, see if I'm happy with that now. Have we done everything we need to? Yeah, we have unbound it, we put it back to 0 to unbind it, and we stored the VBO for deletion later. Excellent. Right, what else do we need here? Oh, unbind VAO. No, let's do create VAO next. Shall we? Well, no, we'll do unbind VAO next because we can. It's obvious what that is. We know how to unbind things. So it's going to be GL bind. This time it's going to be a vertex buffer. Is it vertex array? Object. Vertex array. Is it just vertex array object? Array. Right, okay. And it's going to be 0. Because there's only one of those, isn't there? Yeah. So that's it. Yeah, that's the whole unbind VAO bit. Bind indices. We'll do the create VAO next. Yep. Store bind. Let's have a look which one's the easiest one to do. I'm going to do this one next so I don't have to come back to it. Okay, bind indices VBO. This is that special VBO that I was talking about. It has a number of indices, which isn't number of indices. It is that one there. Sorry, my bad. Let's get the naming conventions the same, shall we? There we go, that one there. Just change more, please. Thank you. Makes it easier when I come back to check on things that I use the same names. They don't have to be the same names. I could have just left it as it was. It doesn't really matter. But it's just for me, when I come back to check on it, that I check that both ints and that they're both used for the same purpose or the correct purpose. That's all. That's the only reason why I name them the same. No other reason. So, bind indices VBO. First of all, we'll need a VBO, won't we? So, same as just below here, we'll have a GL uint VBO ID. Yep. In fact, copy and paste time. Because then it's going to be generate buffers. And then it's going to be bind buffer. But it isn't an array buffer. I told you it was special and I meant it. Because in here, we are going, because it's an indices, it isn't like an array, a normal array buffer. It's comprised of elements, single numbers. It doesn't need to know how many number items per data. It doesn't need to know the items per data. That's what I'm trying to get at, because it can't be anything else. So it is actually a special array that it lets us use, called an element array, I believe. Yeah, element array buffer, which is 8893, whereas the variable one is 8892. See, next door to each other on the graphics card. Bump. That's that bit done. What do we need to do now? Not much. We just need to send it the data. That's all. As I said, it doesn't need to know the size or what. It already knows what to do with this stuff, because it's specially set up for it. So GL buffer data as before. This sends it down. The data sends it to the card, graphics card. And it's going to be GL underscore element array buffer. I'll type all that lot in. There we go. Now it is looking for the size, so size of indices. Now it makes more sense, doesn't it? Now it's looking for constant void star data, which is indices. It's already got a star on it in Indices. And then it's looking for that glm num usage. That's interesting. That's a GL static draw. Yeah, so I'm wondering why it asks for that. We're not going to be changing them. I suppose, yeah, we could. I know we could put it as read and write, couldn't we? Yeah. Yeah, I suppose, yeah. Might want to put it as something different. I think that's what it's saying there. Where's my coffee? My coffee's going cold, which means I now know that we are where. Yeah, we're past the 30-minute mark, and we've only just got that far, so we're on create. glbuffer data. Do I need to unbind it? Not really. No. Not really at all. You can only have one open at a time, so this, I mean, it's not like it's going to be multiple types of indices element arrays. There's only going to be one, so no real need to unbind it. We can be lazy. It's really. I've never unbound it in the past, so why start now? VBOs. We are going to need to push it back though, because we do need to delete it later. Push back. The address, please, isn't it? Yep, double and. The address of VBO ID. There we go. Double check my notes, that's right. Yeah, I'm happy. I'm happy. So we now have OpenGL. So we now have the data of our model sent down, GLSL setup, our indices setup. We need to get our VAO set up to hold all to store our menu. So we better create this now, haven't we? This should be an easy one, actually. GLUint. You're getting the hang of this now. Shall we call it VAO? Yeah, why not? VAO. May as well be consistent. So, yeah, GL. Guess what it's going to be, Jen? And it's going to be a vertex array instead of a buffer. It's going to be a vertex array. And we're going to use just the one. I'm doing one model at a time. And we'll want the address, don't we? Yeah, star address. Address of VAO ID. Oh, this is starting to look easy. It isn't complex. It's just fiddly at times. And because you've just got to remember which bits do which bit. Yeah. So we generated it. Oh, yeah, we better bind it, haven't we? GL bind vertex array. And that's just going to be VAO ID. Straightforward again. That's correct, isn't it? Yeah, thank you. And we don't need to do anything else. So we'll store that for later, so we can delete it. Push back, please. And it'll be the address, yeah. It's got a star on it, so it's VAO ID. And then this time, we will want to return the value as a GLUint. If you see, we've got the GLUint here. So we are going to have to return that value. And we do need it because if you remember, we're going to be storing that into model base at the end of the day. So VAO ID, put the command in, there we go. That's that one done. So all we have to do for the VAO, it's the easiest one of the lot, is just generate it, bind it, push it back, in other words, store it, and The only reason why I've done an unbind VAO at the end here is because we do have to unbind it at the end. So what we are going to do in here is create it and unbind it, and then in between we're going to do all of our VBOs. So it stores them underneath. If that makes sense. It will do in a second. Low texture we'll leave for a second. Do we need to? Yeah, we can leave low. That one. Yeah. Okay. we've now got everything filled in, so we can do the top one, and then I can do the disruptor. Yeah, that's good. It's only the texture I haven't done there. Right, so what we need is a GLUint VAOID. Again, I'm going to call it the same name. You don't need to, but I am just for, you know, easier for me to remember and know what things are doing. So that's going to be create VAO, which we've just written. So that's the first thing we have to do. Once it's created, every single VBO that we create after that will be automatically registered by the graphics card to this VAO. It does that for us. We don't have to give it a command to do it. It creates this menu system here automatically. So it creates this menu for us, so that as soon as we create a buffer, a VBO, that pointer will be added to the VAO array automatically. So that ID pointer will automatically be stored on our graphics card under this VAO ID. So it will have VAO ID, and then it'll just be open brackets and a list of VBOs. How it stores it. That's how it does it. Just wondering if I need anything else there. Nope. Next thing we want to do is just follow this here. So we'll do the special one first. So I've created our VAO. Then we'll do the special one, which is going to be bind Indices VBO, which we've already written. And that's going to be size of indices, comma, indices. Simple as. There we go. So yeah, it doesn't half make it easy, does it? So that VBO will now be registered under whatever's created there. Our indices have been recorded. They've now been literally sent. They are now on our graphics card. After that line, they are on our graphics card, stored, ready for use, and they've been registered under that ID. All done for us automatically. Isn't that nice? Now we get to store data in attribute lists. We get to our next command that we did. Is this one. So we will do store data in attribute list, and the first item of data I'm going to place in attrib number 0. It's up to me. I can use any number I want as long as it matches up. When we do the GLSL, it's got to match up. When we write our GLSL code, I'll come back here and I'll refer to it, and we will be referring to that 0. I will have to do that, because if we get it wrong, it doesn't work. So that now is size of data, which is size of positions, please. Yep, so that's in. Next is items per data. Well, 3 vertexes per triangle. Now, way back when I was doing the object loader, I talked about quads. Now, if you do decide to go ahead and include quads in that object data, you also have to do detection here. So if quads has been set to true, or if quads is set to false and you're using this line, If quads is set to true, then you're using this line, except that 3 is a number 4. It's as simple as that. I mean, it is not rocket science to add it in later, which is why I just skipped over it, and I probably will add it in later. There we go. Positions. That's correct, isn't it? Yeah, it is. So you can guess what the next line is. Store attribute list. And this time we're going to use the next position, which is number 1. We'll use this for size of text chords. And that is going to be 2. 2 items of data. There's only 2 coordinates per data set. And what do we call it? Text chords in here. That's it. Text chords. Am I starting to make this look easier? Is it all starting to fall into place for you? And it's the reason why I wrote them first, is so that you could understand that each of these is doing something, and you can see what it's doing rather than me just do this first, and you're wondering what the hell these commands are, thinking they might come from OpenGL or something. No, we've just written them, literally. Number 2 is going to be normals, isn't it? Yeah. Oh, wrong one. Normals, please. There's 3 normals. Well, there's actually 3 items. Same as vertex, same as positions. There's a normal per position, put it that way. And we put this in pluralized normals, yeah. There we go. Sometimes I don't plural it. So we create the VAO. The graphics card then handles the VAO at its end and stores each one of the VBO IDs that we create every time we say create or gen. Each time we use an OpenGL gen buffers, it will give us the address on the graphics card, and that graphics card will also put that address under wherever it's stored that on the graphics card, and the address for that is given into here. Well, actually, it gives it a number. So the first VAO is probably number 1. So when you tell the graphics card use VAO number 1, it will look at its VAO list, which it has a special place on the graphics card for them, and it will see, oh yeah, we need these VBOs. You're allowed up to 32 VBOs normally. Not sure, you'd have to check with your graphics card manufacturer whether they've gone up to 64 yet. It depends if it's a 32-bit or a 64-bit machine, I suppose. Graphics card. I think they're probably 64 by now. They must be. I can't understand if they weren't. And as I said, once you've finished with that, you do have to unbind the VAO. And that is important because that tells the graphics card that we're finished with it. And that means that if we do carry on and we make another GL gen buffers, it doesn't then get recorded accidentally under this VAO because it's automatic. So we're protecting ourselves. And this is where the fun starts, because we return a value from this. And if you remember, we're going to be storing in model base. So it's going to be models, colon model base. And what does that need? That needs a VAO ID. Yeah. Okay, VAO ID. And it needs an index count. I called it index count. Well, it isn't. It's size. It's the same thing, actually. Never mind. I'm not happy about that, because the two things aren't exactly the same. If there is a problem I'm going to leave it as it is, because if there's a problem with our indices, I know where it is. It'll be that this is the size of indices, which is the number of indices times the size of an int, whereas the index count is just the number of indices in my mind. So I will look at that. That's a little thing that I didn't spot before, although I'm using it as the same thing. Weird. That's bad of me. Well, that information we then store in the model base, which can be used. So what we will be doing is we'll be creating an object called my model base, or cube, and then you put base, or cube base equals, and then you will put load to VAO, and what we're going to have in here is a load to VAO, a loader, and then a comma, and possibly texture or name, file name. Yes, got it now. Excellent. Fine, I know what I'm doing. Yeah, I'm just thinking of the final usage. Do apologise, but that's how it's going to work. You'd love it on the final usage because it does actually make it very easy. As you can see, once you program the functions, the language is very easy. So, in the destructor, as I promised, we are going to destroy every single one of these things that we stored. So, first thing we can destroy is the VAOs. So, for each VAO, we are going to take for each VAO, why don't you call it VAO singular? It's not an S at all. So, each VAO in member variable VAOs. Yeah, that's right, that's a for loop. We want to GL delete, and it's going to be the vertex arrays, isn't it? Yeah, vertex arrays. We'll do them one at a time for each VAO that we've stored into the member variable VAOs, which is a vector. And that's just VAO. We'll destroy each one, please. Delete each one. And we have to do that for each one of the member variables that we have done. So the next one is VBO. So that's VBO. VBO. And this is now delete buffers. Yeah. Okay. There we go. And that is 1, VBO. Is that correct? VBO, VBO. For each VBO that we have stored in the VBOs, delete each buffer. That's right. And the last one that we stored was text. Was it? Oh, yes, it is actually. We just haven't done the thing. It's here. So that is m underscore text ID. If you remember rightly, when we were doing texture loader, I said don't, whatever you do, put a destructor in here for your texture IDs. because it will be handled elsewhere. It's handled here. Our texture IDs, we can handle it from anywhere in the program, the destruction, but we handle it here because this is a central location for all of the information. All of the data passes through this one file. It's the only file in the library which all data passes through. So we're doing it here. And that's going to be mtext ID. And each texture is going to be delete textures. There we go. Yeah, that's right. So we've got GL delete vertex arrays for the VAOs, GL delete buffers for the VBOs, and GL delete textures for the m_texture ID. And if you remember rightly, did we store it? Did we store it? Yes, we did. But not in the way I think. It's there. That's where the texture ID is going to come from. I thought that I might return it as a return value from DataLoader, but as it's a class rather than a function, I don't think putting a return value is a very good idea. I don't like putting return values on classes. On individual functions, yeah, that's fine. You can do what you want. But when it's a class, you can, but tempted not to. m_text ID, we haven't got it. What? Yes, we have. It's here. Why doesn't it like it? I wonder. Oh, it's not defined, is it, anyway? Have I put these in as... No, it's because they're stars. That's why. Yeah. Okay, texture loader. Trying to see whether I have them. Ah, wait a minute. Yes, I have. No, it's me being stupid, isn't it? It's text, not text ID. Oh God, learn to program, Blades. Learn to program. I bet you, if you haven't seen a for loop done that way, it's a shorthand version of saying for I equals 1, 2, I is less than VAO, I++, and then going through each I inside of the vector and deleting each one that way. So you could do it either way, but that's the easy way of doing it, I think, really. So the load texture, finally, the last bit. So yeah, string, file name, yeah. Now I preempted this one way ages ago. I altered my code. So if you didn't spot that in a previous episode, and I did it craftily, what I did is I put all my textures, I just dragged them all into a new header, a new folder called textures. So I just dragged them all just to put them all in one place. So I knew where they were. And I wanted to know where they were for this because the only thing I want to do is type in load texture, open brackets, blue or gold or terrain. I don't want to know where it is. I don't want to know that it's a PNG. So what we're going to do is std : string. And we are going to call this path equals open inverted commas, and we've called it resource, haven't we? And then it's /. And then it's textures. I've named it. It's whatever you've named it. You might have done it differently to me. No, I don't mind. You can name it anything you want. Remember, any of these names can be changed. It's up to you as a programmer. You can do what you want. It's the bits in yellow. you need to be aware of. Changing those is always a bit tricky. So it's C++, so I can just put plus. No reason why it's called C++. No. File name helps. And then that's plus. And then we're going to put .png. So all I have to do is type in the literal file name, i.e. blue, gold, or terrain, and it will go and get it for me. Now, if you were to distribute this, or you were trying to execute from here inside the exec folder, it would give you an error because it won't be able to find it. When you transport the program, you have to transport the resources folder with it. So you would have to take the resources folder, copy it into exec, and then take the whole of exec and copy that out to your transport. That is your then transport file. You'd take all the object files out and clean it up properly. But then it would have your exec, it would have your resources in there. The other file that it wouldn't be able to find, no? Have we used this somewhere else? Yes, we have OBJs. It's in resource again. So I think, did we do the same with OBJs? We should have done. I usually do, because it makes it easier. When you're running from here, the working directory is whatever you set it to. I put it in here. There you go. Current working directory is set to test. So it will look in test, and then it will go on to whatever path we've placed in. So test/resource. Yeah, that's correct then. It'll find it every time. Not a problem. Muppet, you are definitely now going to have to move, because I've nearly finished this. And it still doesn't like mtex. Learn to program blades. I'm going to shout at myself in a minute. Come on, Muppet. Move, move. No, serious, move. Come on, move. Come on. Thank you. Thank you very much. So, we're getting it from the right place. Now, we need model. No, we don't. Where's our texture loader? It's in API, isn't it? So, it's just texture loader. There you go, texture loader. Texture loader. I'll call it texture. Open brackets. Why aren't you giving me anything? We did put a path on it, didn't we? Yeah, file path. Thought so. It's not file name notes, it's file path. That's why I name the things differently. So yeah, we've already done that bit. So that will load our texture. We then have to push back and store our texture in mtext text ID. That's it, yeah. So m underscore. Remember, texture loader actually loads it straight onto the graphics card, and it does produce a texture ID. So we're just going to nick that, and we're going to use that here. So let's do that there. This is becoming a long episode, I apologise. It's my slowness. So I want mtext ID. Thank you, Brain. Push back. And and we will want to push back the address of the text ID, which is texture dot, and you'll say it now, get ID. There we go. Now, why don't you like that? And we're not allowed to do that in the pushback. Oh, right. Yeah. What I'm trying to do is I'm trying to write it all in one line. I haven't split it up. Oh, that's silly of me. That is very silly of me. Because it doesn't know what type it is. It's an AND gluint. Is that correct? No. Okay, let's split it down then. Simple as. So it's GLEUint. What do you want to call it? Anything will do, won't it? So just call it text ID. Keep it simple. Equals that part. And then that becomes push back the address of text ID. There you go, that'll work. Yes, we do. I just realised there's a gluint here. That's what I was looking at, and I was thinking, why have I put a gluint there? And I just thought return text ID might be a good idea. Why return the text ID? Because we actually need to know what it is for when we use our texture. If you remember, model texture there uses it. So model base plus the texture goes into model texture. It's good. Yeah, it's all thinking through properly. And that's the whole thing. That's everything. A bit more complicated than I would have liked it to have been, but I hope that you realise that by doing it in that order, it works. And really, I should have done that as well. What I normally do is I put in that as a little marker. Okay, that's correct, I think. Yeah, that's right. So that should make sense to you now. That everything above here is what the user uses, and by user I mean destructor as well. You can make the destructor private, I suppose, but there's no point. So we've got the load to VAO, which uses all of what we've got in the private area. We've got our load texture. So we've got everything gets loaded through this data loader, and that is the point to all of this exercise. This is the heart of everything. That's all there is to it. Data loader is the hub. After this, in this series, we're not doing any more C++ programming. That's the end of our C++ programming. Unless you want me now to go back and do object loader, convert data, because I know what it is now. The convert data has to provide If you remember here, it has to provide that there. That's where that's coming from. And texture loader, was it? No, it wasn't texture loader. What else did we? It's terrain. Yeah. I couldn't do the terrain because I didn't know something. Yeah, API loader, you see. I need the API loader. So we now have it because the API loader is now called DataLoader. There you go. So yeah, I needed the data loader because as I said, or what I was trying to get at is to generate the terrain, we're going to use a texture height map. And to get the texture, I need to use the texture from the data loader. Yeah, because it's there. I need to use that function there, load texture. That's why I was stuck. So yeah, that's everything done. I am so happy about that. I'll just save that. That's already done. That's already done. Everything matches. Nothing's going crazy. GLSL, will it accept? It might not. I'm going to try this. Control Shift Build. Control Shift Build. Yeah. Expected semicolon before texture. Yeah. Great. Why? Because it expected a semicolon. I know. Right, what's the error? I've made an error 38. The line before 38 I'm interested in. Line 38. Semicolon. Semicolon. API texture loader. Statement cannot resolve address of overloaded function texture loader, texture path. Right. That's fine then. That means I've overloaded it. That's okay. Oh, yeah. Yeah. All right. Let me just try something. Yeah, it's going blue. Texture isn't actually something, is it? See, it's not coming up with a red squigglies because it's right. We have an overload. So I'll sort out the overload. I'm going to let you lot get off because we're now on 120 and it has been a bit of an episode. You might need to look at it a couple of times. If you watch it twice, then you'll definitely get it. I think you can't not get it really. It's just followed the same rules as before. We've just done variables, no constructor, but we do have a destructor for once, the only destructor we've made because we have to. Couple of these are the two functions that I need. One to put the model through to the graphics card, and one to put the texture through to the graphics card using something that it's telling me there's an error on. I'll look at that and find out why. And we're just using these as conveniences, really. Convenient ways of doing it. And that's it. There you go. Thank you very much for watching. And have fun. I'll go and have a look at some errors. Because I want to know why it's giving me these errors even though it isn't. It's lovely when it does that. So, catch you later. Have fun.